Hello friends, in this tutorial I'll be talking about bidirectional autoassociative memory, that is BAM. So this algorithm also consists of two phases, that is training algorithm and testing algorithm. So let us talk about training algorithm first. So in training algorithm, we first obtain the weight matrix. The weight matrix can be obtained in two ways depending upon what kind of input patterns are given in the question. If the input patterns given in the question is binary, then the weight matrix is obtained using this formula, where SP represents the input patterns and TP represents the target output vector for the corresponding input pattern. And if the input vectors involved in the question is bipolar, then we obtain weight matrix using this formula, where again SP represents the input patterns and TP represents the target output vectors for the corresponding input vectors. Okay, now let us talk about testing algorithm. Step 0 is to initialize the weights to store P patterns. That means the step 0 of testing algorithm is same as training algorithm. The weight matrix which we obtain from the training algorithm serve as the step 0 for testing algorithm. Step 1, update the activations of the units in the Y layer, calculate the net input. For example, let us say x1, x2, x3, x4 represents the input given in the question, and y1, y2, y3, y4 represents the corresponding output vectors for the input vectors x1, x2. So what we do is, we first of all calculate the net input to the output layer, and then we apply activation function over it, and then we compare the result with the target output given in the question. If it is equal, then we say that the convergence occurs. That means correct response is obtained. Okay, and the net input to the output unit is calculated using this formula. Y in j is equal to sigma xi wij. What is the meaning of this formula? We shall see with the question. But since this is a bidirectional network, so we don't do it only for the Y layer, we do it for the X layer as well. That means we calculate net input to the X layer, to the input layer, and then we apply activation function over it, and then we compare the result with the target, with the input pattern given in the question. If it is equal, then we say that the correct response is obtained. Okay, so step 3 is what I just told you about, and step 4, test for the convergence of the net. Okay, so that is for the convergence. Now what are the activation functions that we use in bidirectional autoassociative memory network? See, yj is equal to 1, it is equal to 0, it is equal to yi, depending upon if y in j is greater than 0, that means the net input, if it is greater than 0, then the output of the activation function is 1. If it is less than 0, then it is equal to 0. And if it is equal to 0, then it is same as the net input if the binary input vectors is concerned. And if the bipolar input vectors are concerned, then 1 yj minus 1, depending whether it is greater than 0, equal to 0, or lesser than 0. Okay, now do not worry about this. Let us see a question, then we will understand it better. Now construct and test a BAM network to associate letters E and F with simple bipolar input output vectors. Target output for E is minus 1, 1, and for F is 1, 1. Display matrix size is 5 cross 3. Input patterns given are C. See this asterisk. Asterisk represents 1 and dot represents minus 1. So we have a pattern something like this. This is E and this is F, where asterisk represents 1 and dot represents minus 1. Okay, and target output has been given minus 1, 1 and 1, 1. So first of all, we arrange that in a simple form like this, where we represent input in the form of 1, 1. For example, here we say ki 1, 1, 1 for E, 1, 1, 1, 1 minus 1 minus 1, 1, 1, 1, 1 minus 1 minus 1, 1, 1, 1. So that is what is written over here. And similarly for F, we calculate like 1, 1, 1, 1, 1, 1, 1 minus 1 minus 1, 1 minus 1 minus 1, 1 minus 1 minus 1. So that is what we have written over here. Targets given is minus 1, 1 for E, and target for F is 1, 1. So that is what we have arranged in this form here. Now, as I told you, since this is a bidirectional network, so let us see. First step was to construct the weight matrix. So weight matrix is obtained using we multiply the transpose of the input pattern and we with the target pattern. That means input is written like this, it is written like this, and target is written as it is like this. So we obtain W1 for E like this, where this is okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is a 15 cross 1 matrix, and this is a 1 cross 2 matrix. So you will obtain a 15 cross 2 matrix here, right? So for E, W is obtained like this, and similarly we do it for F. For f, we write corresponding input patterns for f, and then we multiply it with the target output for f. We get a matrix like this, just like E. So this is a 15 cross 2 matrix here also, and then we sum those two matrices to obtain the final weight matrix. So final result that we'll get after summation of the matrices like this. Okay, so this is also a 15 cross 2 matrix. So first step, that is the training algorithm, or step 0 of the testing phase, has been completed. Now let us talk about the proceeding steps in which we test the network. So testing the network with test vectors E and F. For test pattern E, compute the net input. So as I told you that we have to calculate the net input. So let us see how do we calculate the net input. For E, we calculate the net input by multiplying this, by multiplying the input pattern for E with the weight matrix that we have obtained. So y is equal to this into this, you'll get this minus 12 and 18. So this is a 15, this is a 1 cross 15 matrix, and this is a 15 cross 2 matrix. So what you will get is a 1 cross 2 matrix. So after multiplying these two, you have got minus 12 and 18. Now you have to apply activation function over it. Okay, so this, since minus 12 is less than 0, so we'll get a minus 1 here, and 18 is greater than 0, so we have a 1 sign here. So see, minus 1 comma 1 for E we have got, and in the question it was for E target output was minus 1 and 1. So we have got the same answer, minus 1 and 1. So we say that the correct response has been obtained for the vector E. Now let us see for the test pattern F. So similarly for the test pattern F, we calculate the net input. How do we calculate the net input? By multiplying this, by multiplying the inputs of F with the weight matrix obtained, and then we get a 1 cross 2 matrix, just like in case of E. There is 12 and 18. Since both values are greater than 0, so we'll get 1 and 1. And in the question also, for F it was 1 and 1. So we have got the same answer. So we say the correct response has been obtained. Right now, since this is a bidirectional network, so we check for the X layer as well. That means the target values will serve as the input now, and we have to see whether the we multiply the target value not with the weight matrix, we multiply it with the transpose of the weight matrix. So this is a catch here. See, y vectors is input. Now we'll use y vectors as input. So weight matrix, when y vectors are used as input, is obtained as the transpose of the weight matrix when x vectors were presented as input. So now we obtain the transpose of the weight matrix like this. Okay, so we'll use this now to test in the backward direction. So testing the network for E. Now input will be minus 1 and 1. That means now input will be this target, and the output will be, now we go in this direction. So the now input will be this, and output should be this. So how do we do that? See, we multiply this minus 1 and 1, that is the target vector, with the transpose of the weight matrix. So this is a 1 cross 2 matrix, and this is a 2 cross 15 matrix. So what you'll get is a 1 cross 15 matrix. So you'll get it like this. And after you apply the activation functions, so 2 will be becoming 1 because this is greater than 0, and minus 2 will be becoming minus 1. Why? Because this is less than 0. So now let us compare these two results. For E, it is 1 1 1 1 minus 1 minus 1. Similarly for you will find after comparing these two values that these are same. So you will say correct response has been obtained. Okay, similarly for F, what you do is you calculate the net input by multiplying the target vector for F. Target vector for F is 1 and 1, and you multiply it with the transpose of the weight matrix. So you will get y like this. Okay, you will get a 1 cross 15 matrix here, and after you apply the activation function over it, since this is greater than 0, so you'll write 1, and this is less than 0, you write minus 1, and you compare these two values. That means you compare the input set with the output set that you have just obtained, and you will find that these two values are similar. So you write correct response has been obtained for this also. So we write thus BAM network has been constructed and tested in both the directions from x to y and y to x. So with this, the BAM networks comes to an end. So thank you people for watching the video, and if you like the video, I request you to please like, subscribe and share. Thank you.